Hello everyone. This is the first video in a series of 7 that will talk about the rules for naming organic compounds using the IUPAC rules. The need to name compounds has come about because chemists need to be able to name molecules so that they can have effective discussions about chemistry, especially back in the days when it wasn't so easy to look at the structures if you were in different places. And so the IUPAC developed a set of rules for doing this. IUPAC stands for the International Union of Pure and Applied Chemistry. This is the official body who developed the rules and also other standards related to chemistry. Now, the IUPAC rules allow the systematic naming of all molecules, and that one compound structure would only get one name, and only one name corresponds to one compound structure. The course Moodle has a drill that will help you review and learn these rules, and it's only open for a limited time only, so be sure that you do it before the time is up. The simplest family of alkanes contains only carbon framework and CH bonds with no other functional groups. To name this family, most of you has had probably some experience that it is named according to the number of carbons. Many of you already know the names for the hydrocarbons from 1 to 8. So for 1 carbon it's methane, and that's ethane, propane, butane, pentane, hexane, heptane, and octane. But probably fewer of you know about what's beyond 8 carbon framework or hydrocarbons. And for 9 carbon hydrocarbon alkane, this is nonane, and then it's decane, undecane, dodecane. Similarly, we need to also name the alkyl groups, and we get the alkyl group by taking away a proton so that it has a space to bond at carbon. We get the alkyl groups as follows, and they are derived from the original alkane names. So it's methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl. Nonyl, decyl, undecyl, dodecyl. Now, for a generic representation of an alkyl group, we use this R. And so you can see that for an alkane, a general representation would be RH. To name hydrocarbons, the primary rules are that you must find the longest parent chain and that the substituents should get the lowest numbers possible. So here are 3 examples where the longest carbon chain is an 8 carbon chain, and that means it is going to be a derivative of an octane. However, notice that you shouldn't be fooled by the way the molecule is written on the piece of paper. The longest carbon chain may not be the one that is laid out flat for you. The next task is then to number the carbon chain so that the substituent gets the lowest number. Let us take this first example. If we number it from left to right, maybe this is just because of our typical way of thinking, you will see that if we did that, then carbon 5 would have the methyl substituent. However, if we name it as 1 and then from the right to the left, that means methyl gets 4. So of course 4 is less than 5. That's why the name of this compound is 4-methyl octane. This goes the same way for the other 2 compounds. You might want to pause this video just to look at them and make sure that you see that this is the case. Now, for even more complex hydrocarbons, having more than one substituent, then you will have to number so that the substituents overall get the lowest numbers. And then, if you have 2 of the same substituent, you need to add the prefix di. For example, for this particular compound, we don't say 2-methyl-4-methyl-hexane, you say 2,4-dimethylhexane. And you can mix it up with different substituents as well. Here you have 5-ethyl-2,5-dimethylheptane. If you have 3 of the same substituent, the prefix is tri, and if it's 4, it's tetra. Now, substituents are listed also in alphabetical order. This is why, for example, for this particular compound, you notice that it's 5-ethyl 2-methyl-octane and not 2-methyl 5-ethyl-octane, even though numbers don't seem like they're ascending. This is because E comes before M. Now, when you number the chain this way or the other way, you will notice that the two substituents are both at 3 and 5. So which one is the correct name? Well, we put 3 for ethyl, and this is because even though numbers are same, 3, 5, 5, 3, the 3 should go with the substituent that comes first in the alphabet, and so that again would be ethyl. This is the end of the first video. You may now go on to the second video about cycloalkanes.